In this video, we will discuss a few components dealing with oil burners, looking at it more closely. In this video, we have an electrode and the nozzle holder and the tube for oil that you'll find inside an oil burner assembly. First of all, we will have the electrodes. It will have a ceramic coating over the rods to insulate it from the cabinet or anything to keep it from shorting out. So the current will flow to the end of the electrodes. There will be a spacing between those 2 points, and it will cause a very large spark to form between this, and because of the blower, it will actually come out from the electrode. And we see the oil burner. It will have a tube which have a port for a nozzle to be connected to it. This nozzle will be screwed into the threads, and it will be able to cause the oil to be atomized into small particles so it could be ignited. And so from that point, we will have the nozzle. This nozzle is designed to be able to create a certain pattern on from the little small orifice. There will be information we'll find on it. For example, this nozzle is rated for 0.5 gallons per hour. 0.5 gallons per hour. So at 100 psi, by maintaining that pressure, it will generate a half a gallon of oil. And if you consider 1 gallon of oil is 140,000 BTUs, so this nozzle will create about 70,000 BTUs per hour. Also, it's designed to have a spray pattern of 70 degrees. It has an H on it, which stands for hollow. It will be a 70-degree flame, and inside of the flame will be hollowed out. So they designed these for certain purposes based on the heat exchanger. Another part of the nozzle, it has a filter part of it. It's made out of metal, usually bronze, but it's designed to filter out large particles because the end of it, where it sprays the mist of oil, it's very small. It's smaller than sometimes the head of a needle. Because it's under 100 pounds of pressure, it would be like a spray coming out of it. But it's a very small opening. So they will filter it before it even get to the nozzle. Sometimes they will clog up with debris and things. You have to take them out and clean them. Basically, you can use kerosene to clean it. And you can remove the filter to clean it. It's hollowed out, but it could be cleaned. You can use, like I said, kerosene or some type of cleaning fluid like carburetor cleaner. There's nothing to adjust in this. If they clog up or plug up, best thing to do is just replace it. So they do sell kits for oil nozzles. It would come in a kit like this. It would come with many nozzles in it, and it will specify the GPM, or the GPH rather, the gallons per hour. It will tell you what type of pattern, such as this one. It's a 70-degree hollow nozzle. This is a 0.5 gallons per hour. But anyway, they come out with many different type of nozzles. So a technician will keep one of these on his truck if he deal with a lot of oil burners in his career. A couple other components we want to look at. Take a better look at a transformer. With this transformer, we can see where the electrodes are coming out, the springs, and like I said, it will rest on the this device where you see the igniter, and this transformer, basically the springs will rest on top of it, and it will cause it to spark at the end of the electrode. So the transformer it takes 110 volts coming in, but it produces between 8 to 10,000 volts at these electrodes. This is a newer type. It's designed by a spark generator. It's a little bit more efficient than the older style they had years ago, which was a very large, heavy transformer, but these ones these days produces very good spark, but it takes less windings and less weight, and so it's a lot more efficient. Another device we're going to show is, this is old style primary control. This was the safety control they used on old oil furnaces to control the operation of the oil burner. Basically, it had relays inside of it, had a safety switch where you can reset it if it didn't light within a certain amount of time. And of course, the thermostat wires went to it, but all the wiring for the burners will also be connected to this. But how it sensed it is actually, the old style was using the heat temperature and the stack. So it was a bimetal coil that was inside of the stack. Once it received heat from the burners operating, and it took quite some time for it to happen, in minutes, but it will, since the heat, the bimetal will deflect and cause a mechanical action to keep it operating. But if it didn't have heat and it didn't have the heat to activate the bimetal, there's basically a heater inside of it, the heater switch. It had another bimetal that will cause it to trip the switch that need to be manually reset by this button here. One of the problems was that sometimes a homeowner would come back and keep resetting it, and they could actually put additional oil, raw oil, inside the combustion chamber, which wasn't very safe. The newer styles these days will use a electronic circuitry that will use it to generate the small circuitry right here, all through solid state, and using a CAD cell to sense the flame to cause it to operate. So these days it is a lot more efficient than it used to have years ago.